From figure you can write, we can get the formulas. We can get length of tank, height of tank, clearance between CH is equal to clearance between assembled transformer of tank. This includes the clearance at the base and height of oil above assembled transformer. Normally used values of CW, CWL, CHR as below. This is ratings for CW, CWL, CH. Estimation of resistance of transformer. The value of winding resistance is required to find losses and voltage regulation. The resistance is found out using the values of cross-sectional area of the conductors, number of turns and length of mean turn. Here we can assume RPRS is equal to resistance of primary and secondary winding. LMTP means length mean turn of primary winding. LMTS is equal to length of mean turn of secondary winding. Resistance of primary winding, resistance of secondary winding. Formula is given AP into TP, AS into TS. As we have seen in our first lecture, what this nomenclature means. So once the value of resistance is found, then total copper loss is PC is equal to I square P plus RP. I square S RS is equal to watts. So now per phase total resistance of transformer referred to primary side, RP is equal to PC upon I square P into ohm. Also RP is equal to RP plus RS in bracket TP into TS, TP upon TS bracket square ohm, where TP TS is equal to number of turns primary and secondary winding respectively per unit. Resistance is epsilon R is equal to IP RP upon VP. Estimation of leakage reactance of transformer. We have seen various types of leakages. The value of leakage reactance is required to determine voltage regulation. The value of leakage reactance is required to determine the voltage regulation, short circuit forces, etc. Leakage reactance. Leakage reactance estimation is nothing but estimation of the primary distribution of leakage flux and resulting flux leakages of the primary and secondary winding. This figure shows the distribution of leakage flux in the transformer. which uses cylindrical core type of winding of equal axial length. The leakage field is mainly between winding, that is duct portion. It is to be noted that distribution of the leakage flux depends upon the geometrical configuration of the coils and the neighboring iron masses and their permeability. Permeability. Now leakage reactance of core type of transformer. From figure, the primary and secondary windings have an equal axial length. The leakage flux paths are parallel to the windings along the axial length. The MMF requirement of iron part is very small. Due to high permeance compared to air and hence neglected. Magnetizing MMF, that is magnetizing current, is neglected. Hence primary winding MMF IP TP becomes equal to secondary winding IS TS. Therefore, the total MMF IP TP IS TS AT is equal to IPTP is equal to ISTS. Half of the leakage flux is negligible, so it does not affect the distribution. MMF in winding varies linearly from 0 at one end to full MMF, that is AT at the other end. Here notations is given. The figure also shows two windings and flux distribution.